Welcome to a discussion of anatomy and physiology of the integumentary system. So we're talking skin basically, but it's more than just skin. And so we'll talk, skin is kind of a broad general term, and obviously it's a pretty important covering of our body. So, you know, with skin, without skin makes a pretty big difference, right? So the skin, why do we even have it? Well, yes, it's aesthetically pleasing, and it's funny how much time and emphasis we put onto the aesthetics of skin. So we should consider that part of the function is just social communication, that with our skin we stretch it, you know, with muscles underneath it, so we can smile and grimace, and you know, all sorts of social communication, especially with the face, but any, you know, body gestures. The color of the skin can tell people things about us. Our hair, we spend a lot of time with our hair, a lot of time with our skin, a lot of time concerned about the expressions of this outer layer. So it is communication. That's one role of the skin. And it's funny that we put so much emphasis on these cells and their care and maintenance when they're actually dead. You know, the part that we see is dead. So, and yet we care for it a lot, right? Trying to keep it supple and youthful looking and not wrinkly and stuff like that. It's dead, but it's maintained by living things underneath, and it's attached to the muscles and so forth. So the Human Anatomy Atlas doesn't have the integumentary system really in any great detail, because it just shows the outer layer. But we can zoom in, we can say, oh look, hair follicles. What about hair? Hair is part of the integumentary system too. It's a derivative. It's coming out of the epidermis. It's part of that. Sweat glands, things like that. So let's talk briefly about some of the other functions of this integumentary system. Well, it's a protection against what? If we didn't have skin, well, all of these muscles and nerves and everything, what would happen to them? The biggest problem is that they would dry out. So having an integumentary system is very important for just protecting against dehydration. Now, we still lose water through our skin, but pretty much we're pretty watertight and water resistant, right? So that's one function. Also, if you didn't have skin, you're just walking meat for flies and bacteria and everything else, right? Of course, you're gonna, as soon as we cut into the skin, we're at risk of infection and all sorts of problems. So it's a barrier to the outside world. It's a barrier against dehydration, a barrier against predators of the small kind, and you know, a mosquito or a tick has to find a way through that layer, and any small breaks in the skin can lead to bacterial infection or fungal infection, things like that. Okay, skin is also involved in heating and cooling. Now that's part of the circulatory system, right? And this just shows major blood vessels, but we know that we have capillaries that are all through our skin, and that when we're hot, they open up so that there's more heat loss through the skin, and when we're cold, they constrict, and you know, to the point where we might kind of look blue even if we're very cold. So thermal regulation, it's going to be, you know, the circulatory system's involved, but our integumentary system is very involved as well. And sweating is part of that. So we have sweat glands throughout most of our integumentary system, not here. Well, no, we do have sweat glands. You can get sweaty palms. Where do we not have sweat glands? There are a few places. I don't think you have sweat glands on your eyelids. And yeah, good enough for a basic introduction of what it does. Now let's talk about, let's turn this on and that off. Let's go to this is the anatomy and physiology software here, and let's start with the skin layers. Okay, and oh, by the way, the skin is considered the largest organ of your body. And so if you ask somebody what's your largest organ, they may think for a little bit and say, well, the liver, or maybe they'll guess the stomach. The liver is the largest internal organ, but the skin makes up, I was going to say 7% of your body weight. That sounds a lot, and I don't know if it's that high. The integumentary system. We have epidermis, that dead layer, mostly dead. The very bottom part of the epidermis isn't dead at all. We have dermis. Sorry, so epidermis is all this, and this is the layer that's dead, the stratum corneum. And we have a living layer here, the stratum basale, right along in contact with the dermis. The dermis is this whole region, and then we have hypodermis. The hypodermis is basically where we store our fat, and it's a connection between our skin and our muscles. So the hypodermis, there are some muscles that kind of streak through the hypodermis, but mostly it's an attachment to the muscular system. It basically keeps your skin on your body. And so larger blood vessels are going to be found in the hypodermis, and then we see smaller blood vessels in the dermis, and they extend to capillaries that are at the edge of the dermis, but there are no capillaries in the epidermis. So we have capillaries right up to the edge that will nourish the epidermis, but the epidermis itself does not have any blood supply. And kids will, you know, sometimes take a pin and carefully stick it through, you know, you can push into the epidermal layer and you're not going to get any bleeding. As soon as you get any sort of bleeding, you're down into the dermal layer. So you don't have to go very far. Okay, so the skin is just that general term for the epidermis and dermis together. And like I say, the epidermis is divided into multiple layers, which we'll take a closer look at. But there's the epidermis. The dead part is the stratum corneum, and it's thick. It's depending on where you are on the body, it can be even thicker, and you can have an extra layer in there called the stratum lucidum in areas with high friction, like your lips and your palms and your heels. Now, some other things we see here are nerve endings. Okay, and we do have some just open nerve endings that extend into the epidermis. These nerve endings are mostly nociceptors, receptors for pain, but then we have light touch receptors and deeper touch receptors down here, and they have special names, but your skin it plays a very important role in sensing your environment, hot and cold, touch, pain, pleasure, a lot of sensory information coming in through the skin, so that's quite important. And then we have, here's a hair follicle. So these are epidermal cells, even though we're deep into the dermis. It's an epidermal derivative. And so what we have, you can see that it's an invagination of epidermal cells. So these are all epidermal cells all through here. And you can see that they go quite deep into the dermis. If you get a burn, a first-degree burn is just going to affect your epidermis. A second-degree burn goes down into the dermis. But because you have lots and lots of hair follicles, what you have is little islands all over, little pockets of epidermal cells. And they can grow up and out. And so you can heal from a second-degree burn without needing any sort of skin graft. A third-degree burn will burn down all the way through the dermis, So in the process, it will completely destroy all the epidermal cells. And then you'll just need to get a skin graft, depending on the size of, how big of an area was damaged. So associated with each hair follicle, you'll see a couple interesting things. One, you have a gland that secretes some oil, a sebaceous gland, and it secretes sebum. Now the sebum, the oil, helps the hair and also gets onto the skin and helps the skin. And we're kind of weird because even though we're mammals and we produce hair and we're smelly and oily, we are washing ourselves all the time for social reasons. And after we wash the natural oils off of our skin, then we reapply oils in the form of lotions because we just washed off the oil that our skin needed. There's also a little muscle associated with each hair. This is called the Erector Pili muscle, and its function is to make the hair stand up. Now, in humans, it's basically useless. I mean, when you get goosebumps, that's all your Erector Pili muscles standing on edge. And when is that going to happen? When you're cold, when you get chilled, or when you get scared. Now, if you were really covered in hair, like most mammals, and you got cold, and whoosh, you push up all those hairs, you're suddenly trapping a lot of air. And air is a really good insulator if it's just, if it's not moving, if it's just trapped in spaces. That's what, a foam why we put it in coolers, because it just traps lots of air bubbles, and the air acts as a really good insulator. So putting all your hairs up, when you're cold, it works really well if you have lots of hair, which we don't. And I don't think we have Erector Pili muscles on our head hair anyway, or maybe our hair is just too long to stick up. I don't know. But you can get hair up on the back of your neck, certainly, and people talk about, it made the hairs on my neck stand up when they're freaked out by something. So again, this isn't going to do us much good. On a cat, when they're scared, whoosh, all the hairs go up, or a dog, and you see that ridge of fur, and they arch their back, and they're going to look bigger and more menacing. So it serves as an important signal to your opponent that, hey, I'm dangerous. And humans, oh, I'm so mad. Look, can't you tell? Look at the hairs on the back of my neck. No, it doesn't do us any good. But we still have the muscle, the Erector Pili muscle. Here is a sweat gland, and you can see that it's, it is an exocrine gland, meaning it has a duct, and whoop, it secretes watery solution with some electrolytes in there as well. And so we do lose water through the skin, and we lose electrolytes through the skin, and then we drink Gatorade, which is essentially flavored sweat, right, to replace when we're concerned about replacing our electrolytes. I mean, yeah. Anyhow, zooming in here, we can see this is called a basement membrane. It's this little layer between the dermis and the epidermis. And you also see that the dermis is shaped, it's all these ridges and valleys. So the part that pokes up is called a papilla, and so you have all these little papillae sticking up, and the papillae of the epidermis fit down into these little valleys of the dermis. This just increases surface area and contact between these layers. Again, remember that this is where the blood supply ends. So these cells get all their food and oxygen through the blood vessels that ended right below them, and that's enough to keep them alive and well and reproducing. So this whole basement layer, or stratum basale, the basal, or that's basal, bottom, stratum, or the strata, different layers. So stratum basale is where the cells, they're stem cells. They are skin stem cells. They're reproducing all the time, and they get pushed up and away, right? They get pushed up and away, and as they go up, they start to die. You know, they get farther and farther away, and so they're suffering. And as they suffer, they start to produce keratin and harden and become keratinized and dead and tightly held together. Now they hold together with these connections between them, and you know, this layer, they're all dead and really squished together already, kind of glued together. This layer here, they're still alive, and they've formed these connections, but you can't really see it. But if you dry this out unintentionally, so when you make a slide for your microscope of a cross section of skin, this layer, the cells dehydrate, and what's left is kind of the connections holding the cells. It makes the cells look spiky. Looks like they have all these little projections coming out from them. And so the layer is called Stratum Spinosum. And in this drawing, Stratum Spinosum doesn't look like anything because the cells look pretty normal. So it's in a micrograph where you notice the Stratum Spinosum. You know, the cells look spiny because they're somewhat dehydrated. So we have Stratum Basale and Stratum Spinosum and Stratum Corneum. And again, there can be kind of a thick, clear layer called the Stratum Lucidum that's under the Stratum Corneum. Okay, that's all good. Hypodermis is fat storage. So humans are different from most primates in having this under the skin fat storage. And it's also connective tissues. There are different types of connective tissues, and we kind of skipped, or I didn't talk about, you know, elastin and collagen fibers, and but anyhow, we've got I was trying to say that having a hypodermis with a fat storage is not standard among mammals, and for primates, I think humans are unique in having that under the fat storage. So a gorilla is going to store the majority of its fat just inside of its abdominal cavity, like on some of its organs, and it really doesn't have a good capacity. You can feed a gorilla Twinkies all the time, and he's not going to develop a great big. He's not going to become obese. He can't. He doesn't have the amount of fat cells, but we do, and you know, this probably has helped all of our ancestors at some point in time, you know, make it through some period of great starvation and famine, because they were able to store a lot of energy in their hypodermis. And frankly, you know, this is emergency storage here. My body doesn't want to get rid of this because who knows when the next famine is. So my body wants to put more on here because that's such an efficient way to store energy, and it's, you know, it's able to walk around. But another interesting thing is, where do we see hypodermis with fat storage? And that's in aquatic mammals. And this is actually lends support to the hypothesis that humans had an aquatic or semi-aquatic ancestor at some point in time. Okay, good for that, except I didn't mean to close the whole program. I just meant to close that layer. Open it back up. Integumentary system, integumentary structures. Well, we talked about skin. We talked about hair. And it's not just the hair on top of our head. We've got hair all over our body. So, whoops. What else do we have here? Skin and hair. Oh, and we have Sudoriferous glands as well that make us smelly. You know, mammals rely quite a bit on smell humans not so much, but mammals in general rely quite a bit on smell, and we concentrate sudoriferous glands like in our armpits and in our groin. And you know, whether you identify anybody by smell, probably not, but it's a mammal thing. We talked about the protection layer. We talked about tactile receptors. Yes, we have all sorts of nerve endings. Let me go back to, let's see what we got here.
Integumentary system provide a barrier between the environment and tissues and organs within the body. The skin is the largest organ in the body. It absorbs nutrients, regulates internal body temperature, and
it absorbs nutrients. It's not absorbing vitamin D. It makes vitamin D in response to the UV light. It converts a molecule into vitamin D, but it doesn't absorb it. And it's actually mostly protecting you against sunlight, right? Yes, it needs sunlight to produce the vitamin D, but I forgot to mention the melanocytes, you know, the cells in the basal layer that produce melanin, and then that melanin gets secreted and gets into other cells of the epidermis. And the more sun exposure you get, the more melanin that's going to be in your cells as a way to absorb the UV light before it hits the DNA in the stratum basale, because you don't want to do damage to your DNA and end up with potential cancer. Well, of course, worth saying with melanocytes that different people from different regions of the world, different races, have different numbers of these melanocyte cells, and so they're producing different amounts of melanin. So they have lighter or darker skin. Now, darker skin is the ancestral condition, and it's thought that lighter skin was an adaptive response to less sunlight. So as humans left Africa and migrated into more northern climates, those with lighter skin would have been more likely to be healthy and survive and reproduce than those with darker skin, because there's less sunlight available at the northern latitudes. And you have some people, some tribes that live far north that don't have lighter skin, and in those tribes traditionally they had the diet of maybe like whale blubber or seal blubber or something, you know, fish livers, something that contained high amounts of vitamin D. Anyhow.
Eliminates waste. The epidermis is the outermost layer of skin that provides a barrier between the body and the surrounding environment. The dermis is the middle layer of skin. Sensory nerve receptors in
the little bacteria bouncing off was kind of funny. Of course, you have bacteria all over your skin, but by and large, they don't grow well on your skin. It's dry, it's salty, and the pH, the sebaceous glands lower the pH of it, so it's slightly acidic. So acidic, salty, dry, not good growing conditions for bacteria. So they're there, but they're not really growing well. Now, some Propionibacterium acnes likes sebaceous gland secretions, and when we are going through puberty and produce more sebum, sometimes those bacteria get a little too happy and they'll infect the hair follicles and we get pimples.
Dermis respond to touch and pass signals to nerves of the peripheral nervous system.
So the touch thing, if you have a third-degree burn and you need a skin graft, then you end up with no nerve sensation in that region. You can't feel anything. And sometimes you think, oh, that'd be nice to not feel pain. No, it's not nice. There are kids who are, it's a rare condition, but there are kids who are born with no ability to feel pain, and they injure themselves in ugly and dramatic ways. Like these kids will chew their tongue off, you know, just because it's something weird in their mouth and they can't feel the pain. And so just as a baby, they'll, you know, as their teeth are coming in, they'll sit and chew on their tongue to the point of damage, or they'll scratch their eyes out. I mean, you got to, you know, put mouth protector in and eye protector, and you know, you find this out when your kid starts harming themselves in terrible ways, you know, just digging into their skin or something out of curiosity. And later on, these kids may actually die from internal injuries. There was a kid in England who had this condition, and you know, as an 8-year-old, 9-year-old kid or whatever, he's impressing all of his friends by jumping off of high objects and landing, and you know, just laughing it off because he doesn't feel the pain. But it doesn't mean he can't injure himself. And so that particular story, I can't remember, you know, how high of a structure he jumped off of, but he didn't feel pain. His body was damaged internally. He ended up bleeding to death from that. So pain's a good thing to feel. Okay.
Glands reduce body temperature by releasing sweat. Sebaceous glands produce an oily substance that lubricates skin and provides protection from bacteria. Blood and lymphatic vessels in the dermis supply the skin.
Tear ducts. Tears also have some antibacterial substance in them, an enzyme.
The hypodermis is the deepest fatty layer of skin tissue. It is in contact with the muscles underneath it.
By the way, this hypodermis, I have tried, I haven't done much, but a little bit of tanning hides. So like you skin a deer and you want to turn it into leather. Well, part of that is scraping the flesh side, and you're essentially just trying to get the hypodermis off. So you want to be left with just the dermis. And if you see leather, like the grain side of leather, the grainy side is the top of the epidermis where all the hair was. So you try to scrape the hair off without damaging the epidermis. And to do that, you soak it for several days, or soak it in lime to make the hair essentially just fall out. So that it takes very minimal scraping. So you preserve that stratum corneum, and it looks nice as the grain of the leather. And then the other side always looks rough and kind of fuzzy because you've mechanically scraped it with a knife to remove the hypodermis, because you don't want that because it would rot.
The skin, nails, and hair of the integumentary system provide a barrier between the environment.
Maybe that was the end. Okay. Menu. Integumentary functions. I think we just talked about that. All right. Skin layers, epidermis layers. Let's go through here a little bit. So, I didn't get I talked about the spinosum, but not the granulosum. So there's our stratum basale, and by the way, there's a little melanocyte, and here are some other melanocytes. There's one there. They stand out more in a, that might not be a melanocyte, this one. These are melanocytes. They stand out more in a micrograph. That special cell is associated with the nerve ending, and probably when it deforms, it sets off I'm not sure what kind of nerve ending that is. Okay, stratum corneum is the outermost layer, keratinized, dead cells glued together. Stratum granulosum is what's right beneath that. Stratum spinosum. So stratum spinosum, they're not dead yet. They are, but as the edge of the stratum spinosum is basically, this is how far away I can get, and you know, away from my life support, and not be totally panicking. And stratum granulosum is, I'm dying, but already they're starting to keratinize, you know, starting to change their function in the stratum spinosum. And then in granulosum, this is their final act. Everybody hold together, hold on, glue together, excrete keratin, become hard, no, we're dead. And so you can see, you know, we lose the nuclei. They're just dead cells. And things are falling off in chunks everywhere you go. They're just always flaking off. And it takes about 7 weeks for cells to progress from the bottom to the top. So essentially you have new skin every 7 weeks, 7, 8 weeks, someplace in there. What's next? Types of skin cells. So a just regular old skin cell is called a keratinocyte. And oh, that was a Merkel cell, that one that was associated with the nerves, the nerve ending. So it detects touch stimuli, transmits touch signals and sensory nerves. So basically the Merkel cell, when you squish it, it stimulates the nerve ending. Fibroblast cells are producing collagen, so just helping hold everything together. Langerhans cells are kind of like macrophages. They are a type of immune cell wandering around because you are going to get bacteria that break through, you know, eventually. So you have Langerhans cells ready and waiting. So keratinocytes, again, this is just your regular skin cell. Most cells of your skin are keratinocytes, and kind of their function in life is to produce keratin, you know, this protein that hardens the skin and makes it waterproof and helps glue it together. And your hair is, you know, just mostly keratin protein, and the horn of a rhinoceros is keratin. Now antlers are not keratin, but horn is, it has a keratin sheath. And then the melanocytes that produce the melanin, which the melanin is going to be absorbed by the keratinocytes, so they'll have little dots of melanin in them, and it helps absorb UV light, or, you know, the UV radiation, to prevent damage to the DNA. Okay. And where are those melanocytes? Langerhans, yeah. Good. Langerhans cells for immunity, Merkel cells. I wouldn't mind. You know, and let's see. Dermis of the skin, hypodermis contain touch receptors or sensory nerves, tactile or Meissner's corpuscles. These, I think, are the Meissner's corpuscles, located in the dermal papillae of hairless skin, such as fingertips, nipples, lips, soles, clitoris, tip of the penis, tip of the tongue. Each oval corpuscle is enveloped by connective tissue capsule. Okay, so these are not Meissner's corpuscles. Merkel cells are found in the stratum basale of the fingertips, lips, hands, external genitalia. Lamellar or Pacinian corpuscles are found in mammary glands, pancreas. So mammary glands are modified sweat glands, essentially. Produce extra proteins and fats and stuff too. Free nerve endings like these are dendrites that detect pain, temperature, itch, tickle. Merkel cells transmit signals related to touch. Meissner's corpuscles detect light, touch, pressure, vibration. Pacinian corpuscles transmit signals related to vibration and pressure. So I think these are the Pacinian corpuscles down here that detect the deeper touch and so pressure and vibration. Meissner's corpuscles, I think, look similarly, but they're up higher and they're in sensitive areas. Okay, that might be good for what I've got with integumentary system. Oh, we do have different layers of the dermis. There's the papillary region, the reticular region, where you have more connective tissue, the Meissner corpuscles down here. We talked about sebaceous glands and sudoriferous glands, which these are technically epidermal, but they're deep, they're invaginated into the dermal layer, and the hair follicles themselves, and you can learn more anatomy on the hair follicle if you want. But just to show regions real quickly, the papillary region is just this region that forms the little projections, the little papillae, and the reticular region is where you have most of your stretchy fibers. So you know, the stretch and elasticity of your skin is mostly the dermal region, not the hypodermis. So as we get old and wrinkly, you know, those fibers are relaxing. There's a guy, if you look up stretchiest skin, Guinness Book of World Records guy, there's a guy whose collagen fibers or elastin fibers are different, and he can just stretch his skin way out. It's kind of fun to watch. All right, in the interest of time, I think we're going to call that good. If you have any questions, certainly feel free to ask. And sebaceous glands, small in most areas, large in the breast, superior chest, neck, and face. That's where we get more oily. Each gland consists of a single duct, emerges from the cluster of oval or flask-shaped alveoli. Sebaceous glands secrete sebum, an oily substance that is a mixture of triglycerides, cholesterol, proteins, and organic salts. Sebum coats the surface of hairs. Lanolin, which is an ingredient in lotion sometimes, or you see it for new moms to put on their nipples to help them not crack. You can buy lanolin. It is just sebum from a sheep. So again, we wash it off us, and so then we have to reapply it. Well, you can't get your own sebum to reapply because you just washed it off. So instead we buy lanolin, or products that contain lanolin, which is just sheep sebum. And it's a great product. Okay, I think we're going to call that done. Hope you enjoyed it. Feel free to leave questions. And how do I stop?